Hello everyone, this is Kyle Miller, Enterprise Solutions Engineer at DJI, and today on our Digital Twin YouTube series, we're going to be talking a little bit more about understanding mission planning, as well as understanding the mission outputs with DJI Enterprise drones. So a lot of this material, we're going to really dive deep on what you should be thinking about, what questions you should have before actually going on site and capturing data. That will help you both understand what you really need to be capturing, not wasting extra time while you're on site, capturing unnecessary assets, as well as making sure that the data processing goes as smoothly as possible so you can make sure that you get that data back in a reasonable time back to the end user or client. So without further ado, let's talk about the agenda for today. First off, we're going to be talking about understanding what the outputs are that we are looking for, as well as understanding the mission criteria, and then diving into the conclusion and some final thoughts. So when we talk about understanding the outputs, these are the main questions that you should really have going into thinking about how to plan the mission. So we are not at mission building yet. We're not creating flight routes, but a lot of these questions are going to be valuable for understanding what type of flight routes that you should conduct. First off, the very first question is understanding 2D versus 3D requirements. The main question being, does this site that you're looking to go capture require just 2D, or are you looking for full 3D reconstruction? If you are looking for more mapping and surveying, traditionally it's going to be more of a 2D or nadir capture. The validation reasons really are going to help you understand the requirements for mission planning types. 2D, you're going to be able to cover a much larger area generally. Compared to 3D, you're going to need to be able to capture all three dimensions of the asset. And if you are trying to capture and reconstruct all three dimensions, it's really going to take more photos, more capture time, and much more detailed mission planning. So oftentimes we get into kind of a rabbit hole of we want to make the best 3D digital twin possible, but oftentimes the data set that the client is looking back at is really only needing to be a 2D orthomosaic map, maybe a LiDAR point cloud mission. So really understanding, do I just need to do 2D or do I really need to focus on 3D is going to help you understand what the mission criteria are going to be. Also, we need to talk about the asset capture size. The main question being, does this need to include the entire asset or just parts of the asset? If you are flying something that is fairly small, this isn't going to be as big of an issue, but if you are going on to a very large job site, I've got some screenshots here of a grain facility. Since I'm based in Eastern Iowa, there's plenty of those. But if we are looking to capture the entire site with fairly high resolution GSD, ground sample distance, or very high resolution 3D models, then capturing the entire site can often take quite a bit of time on site, as well as just capturing a lot of photos that you're going to later need to process. So it's important to ask the end user, the client that you're going to be delivering this data to, or maybe it's even your own data that you're trying to manage. Are you looking to just inspect one portion of the asset, or are you truly going to inspect the entire asset within this one time frame, this one data set? As you can see with the screenshots here, the entire site capturing at 0.1 centimeters per pixel or 1 millimeter GSD. That's going to take us about 1 hour and 45 minutes of capturing the entire site. That is quite a bit of data capture, as well as capturing 11,000 photos. That'd be a very big data set. But if the main focus is really going to be, I just need to inspect the most recent grain bin that has gone up on this site, which would be the south bin here, if I just focus my data set over that area of the capture, rather than trying to capture the entire thing, we're down to about a 37-minute flight and less than 4,000 photos. So it's really important to understand, do I need to capture the entire site, the entire asset, or am I just focusing on new construction or a specific part of the asset that I want to inspect? The next one is going to be, do I need to be making a full 3D representation of a digital twin, or am I going to be doing that inspection on the raw photos? So is the goal to inspect the raw photos or the digital twin? Do you need, this is the main underlying question, Do you need enough overlap for 3D reconstruction or just enough overlap for individual photo analysis? So if the main goal is you want to be able to get a photo of every single side of the asset and then go through the photos and be able to analyze those raw photos, you can do that with significantly less side lap and front lap or general overlap of the asset. Now, even if you do capture a bit less overlap, oftentimes you can still get a 3D model from that data set. The 3D model may not look quite as good, but it can at least be a baseline of where you can overlay the photos on. And then if you click on a certain part of the asset, even if the 3D model isn't quite good enough to inspect and make measurements from specifically, you can then click on that location of the 3D model, pull up where those raw photos have been taken of that 3D model, and then do the live inspection there. Also, there are a lot of instances where users are going to be importing in the raw data set into an AI solution to be able to understand, looking at the raw photos, if there are any defects. That isn't going to require nearly as many photos as making a full-on, high quality 3D model that you want to be able to make measurements on. So overall, you can see, once again, we're pulling up the grain facility instance. If I'm capturing the entire site, capturing 11,000 photos, an hour and 45 minutes of flight time, which can take, multiple hours of just being on site. But if I bump down the side lap and front lap options, I'm down to just an hour of capture with 6,500 photos. So really ask yourself, what is the use for these photos? 3D model representation or raw photo inspection? Another good question is going to be understanding what the ground sampling distance is. We all want to have the best 3D model possible, but depending on what the inspection is really wanting to do, we really need to understand what the requirement of ground sampling distance is. So if there is a set goal that the client, the customer, maybe if you own the asset, maybe it's yourself, understanding what is that maximum GSD that's required, oftentimes sticking to the maximum can be beneficial. We would like to be able to deliver something that exceeds the requirements, but at the same time, that means more flight time, that means more data, that means more processing time. So really understanding what the required GSD or ground sampling distance is can then help you determine how far off the asset surface that you need to be and then how long it takes to capture. As you can see here, we have a hydroelectric power plant. If you were to try to capture the entire asset and make a good 3D representation of that, the bottom screenshot is going to be a 1 millimeter GSD across the entire site. That's going to take over 3 hours of capture and almost 20,000 images. So can you even process that large of a data set? As well as, do you have that much allotted time on site to capture? There's going to be a lot of lighting conditions that may change depending on when you go out there. That can happen over the course of that 3 hours. So does it really require that high resolution, or is the main goal to be able to see maybe a little bit larger defects where the requirement might be half a centimeter per pixel or 5 millimeters per pixel? And that's going to be the screenshot on the top showing you that you could get that done basically on 2 flights. We're looking at about a 51-minute flight with about 5,200 photos. So it's going to be a lot quicker on site, as well as being able to manage the data and process the data a lot easier. Also, it's really important to understand what are the file formats that are required. From there, we can really determine, are we going to be working with 2D orthomosaics? Are we going to be working with 3D models such as a mesh and texture? Are we going to be working with point clouds from that 2D map or 3D model? So asking the end user that needs this data, maybe that, once again, that's yourself, that you're going to be importing that into other third-party softwares, what file formats do we need? We have a couple different options here when we're processing through DJI Terra or even through DJI Flight Hub 2. Whether we're working on 2D maps, looking to export out a TIFF image. TIFF images are generally uncompressed, being able to get you the highest quality, the highest detailed image, as well as when we get into 3D modeling, being able to process that B3DM, or do you need an OSBG, a PLY, or an OBJ? OBJ is generally going to be the most universal when it comes to 3D models. Also with Terra 5.0, we just released a number of new file formats that you can process into. Or if you are looking for a point cloud model compared to that texture mesh, we're going to be able to process that in a PNTS file, an LAS, or a PLY. So make sure to ask or make sure to understand where is this data going so that I can make sure that I'm processing just what is required, being able to hand that over rather than processing something that we may not need. If you just need the point cloud, don't even worry about processing that mesh and texture. Just process the point cloud, or vice versa. And then once again, data size limitations. What are going to be the general data size limitations of the output? That can also go back into what third-party software are we going to be taking this data to after we're done processing. If that's the case, make sure to look up, based off of your own computer specs, as well as the software, what is the maximum allocated file size that can be imported in and can be manipulated. So as you can see here, we have a TIFF image just of a map of a cornfield. That one image, that orthomosaic, is going to be 8.3 gigabytes. Most computers, unless you're using a gaming computer, isn't going to be able to open up a raw image that's 8 gigabytes in size. So understanding what I need for ground sampling distance, what I would want for the overall data size output is going to be very important. There's also the ability, when you're talking about 2D maps, of utilizing map tiling, as well as 3D models. If you're looking at creating meshes and textures, those are oftentimes chunked down so that you have a bunch of grids or a bunch of meshes and textures that you could load in one by one, so that the software that you're using is really focusing on that one specific tile that you're looking at in the real time. So can you tile your data? Is that going to be okay to hand over? And then also, what's the maximum of file size output that you're really looking to be able to import? Because we can make great data sets, but if they're not able to be imported into the third-party software that the client really wants, then generally they're not going to be very valuable. And then last but not least, when you're talking about this, are we looking at mainly visual inspections, or do they need that thermal inspection as well? There's a couple different reasons why we want to ask that. Obviously, when it comes to thermal, you're going to have lower resolution imagery, but you're going to be able to see something that has a radiometric output compared to just what is going on visually. You can see the main difference on the screenshots that I show here. But also, if you are looking to provide thermal where it may not be needed, then oftentimes you're utilizing drones that aren't going to be geotagging the imagery with RTK. If you are able to geotag the imagery with RTK, processing times are improved, the quality of meshes are going to be improved, and textures on that 3D model. So if you're going out and trying to capture something just for the sake of getting thermal, but the end user doesn't need thermal, oftentimes it can honestly hinder you. But there are definite use cases where you need to have that thermal output. And do you need to have both? Are you just looking for thermal, or do you need both visual and thermal? Huge data size comparison when you're talking about needing both, comparing to just the thermal data set. And then accuracy requirements. Does this data set, this 3D model of this 2D map, does it need to align with other sources of data that may already be captured? Does this need to align with the real world with global accuracy, that's within an inch or a few centimeters? Or does global accuracy truly matter, or does this just need to be close to where it can be representative on the world? So question, what is the final required level of accuracy, and is the accuracy requirement absolute or relative accuracy? Generally, when we are capturing data and making a good 3D model, we're having high levels of relative accuracy, but that doesn't necessarily mean that where it's being placed on the Earth is going to be accurate. Relative accuracy, you could actually be off when it comes to scale, but that just means if I measure on one part of the 3D model, and if I measure on another part of the 3D model, if they are the same distances, do they show to be the exact same length on those two different segments on the 3D model? Do you have any warping going on within that 3D model on one side of the asset compared to the other? So really understanding what levels of relative accuracy you need, as well as how accurate does this need to be to the real world Earth. So some of the validation reasons this will affect how we collect data. Obviously, you're going to want to be able to process this data with RTK or PPK if you are looking for a high level of absolute or global accuracy. And it also goes down to the ground sampling distance. If you are looking for an accuracy of 1 inch, but your ground sampling distance is above 1 inch, there's no real possible way of getting your data within 1 inch of accuracy if your pixels are going to be larger than that 1 inch. Next, we're going to be talking a little bit more about understanding the mission. We've answered a lot of questions about what the requirements are from the end user, or maybe from yourself within your own department, of what data do you need, how accurate does it need to be, what resolution you need it to be, and now we can start diving into understanding the mission planning. So first off, it's talking about the asset size determination. This is somewhat similar to what we talked about earlier. Do you need to cover the entire asset? How large is that asset? So the topic being asset size. The main considerations to think about would be the size of the asset greatly changes the complexity and the mission duration. As you can see at the top screenshot here, we have a 3D model of a church that we're looking to fly with 0.11 centimeters per pixel. That mission's only going to take 17 minutes. But if we want the same GSD, ground sampling distance, but we're flying a much larger asset size, that can take up to 2 hours and 46 minutes if we're trying to capture this entire hydroelectric facility that you see in the bottom screenshot. So really understanding how large your asset is before you go out, or before you make any sort of guarantee on what the quality of the data is going to be, is very important. Also, let's talk about the asset shape. This also comes up in a number of other videos that I have created, but this can be very important when we're talking about what mission plans should I use. So the topic being asset shape, the considerations being assets and buildings can come in all shapes and sizes. We know that with the church that I've talked about before. We've got this main structure with a very sloped roof with a pier going on the very far north end of the building, so they can be all different sizes and shapes. When trying to understand the entirety of a site like the church that we've talked about, it's very important to understand what basic shapes this asset is made of. So what does the building look like? The easiest way to understand this, at least from my perspective, is to use the building block technique. Within your mind, can you use children's building blocks to be able to build a rough geometry of the asset? If you can, then you can start understanding what different mission types, based off of what DJI has, or what we will be using. So if it's something that's going to be a tower or a cylinder, can we then use a point of interest orbit? If it's a main rectangular block, are we going to be using a geometric mission? If it's going to be like the triangle that you see, the pyramid that you see on the right-hand side here, are you going to be using multiple different slope missions instead of trying to plan a geometric mission around it? So each side of the building blocks, and sometimes the entire building blocks themselves, can be autonomously captured using one of the flight plans that we can discuss within other videos that are on this playlist, whether it's slope or geometric, point of interest, smart 3D capture. It's also important to know what data capture time is allotted. So how much time do you have on site to capture this data? A very important question when you're understanding your own program or understanding what the client needs. Are you going to be operating over people? Are you only going to have the amount of time that clients are off the site for lunch hours? Are you going to be going on the weekends to capture this site? Are you trying to capture it before or after work? That understanding how much time we truly have is going to help you plan what quality of data and how much of the asset we can cover. So some important considerations here would be battery management. Battery power must be monitored throughout the mission. When the site's rather small, it should only take 1 to 2 batteries when I'm referencing the church. But on larger sites, like you see on the right-hand side, being almost 3 hours long, we're definitely going to need, the whole day of generally not having a whole lot of people on site to be able to capture this site, or at least not a whole lot of things moving around on site. If it's a construction site and they're actively building, things are changing on the site, we don't really have a lot of time to go out and capture all of this data, because from when you started to when you ended, the building may look somewhat different. Mission durations. Long missions may require multiple battery swaps. You're also having a lot of lighting conditions that may possibly change, especially if it's a sunny day compared to an overcast day. You're going to have light hitting it from one side of the asset to another side of the asset just as the sun moves, especially on these longer flights. So how can you minimize the amount of lighting change while you're on site? Also, one final note, overcapture is just going to cause processing times to inflate. So if you're trying to get this data back as soon as possible, then having a lot of extra capture when it's not needed is just going to take longer to process, longer to export, longer with data movement, and then longer to be able to send it. What internet connectivity do you have on site? Is this a very remote site? Are you going to be able to have access to satellite data such as Starlink? Are you going to have a hotspot to your phone? Really understanding what your internet connectivity on both on-site and off-site are going to be very important. There's a couple different reasons here. One may be for accuracy and for corrections. Here in the state of Iowa, I'm usually hotspotting my phone to be able to pull corrections. But there are areas where I don't have hotspot capabilities in a low or no cell area. So if I need to have high levels of absolute accuracy, then I'm going to need to bring along my own base station for that. If I need to be able to process a data set to then mission plan on, I need to be, and I'm looking to, if I have fast internet, I could upload that to Flight Hub 2 and then have that processed very quickly in the cloud and then start planning the mission over. If I don't have good internet or any internet connectivity on site, but I want to be able to do mission planning on the 3D model, I'm probably going to utilize something like DJI Terra to process my data set and then upload, if I can, the raw or the 3D model rather than the raw data, so that I can speed up that processing time, so I don't have to wait so long on uploading a bunch of raw photos. So a couple different reasons why you really need to understand what internet connectivity you have on site. And then also processing requirements, something that I just mentioned about, but also very important. Both processing power, both on-site and off-site. If you're going to be planning these missions over a 3D model, once again, it's important to understand, am I going to be able to process this data set with Terra on site and then upload that raw 3D model? Or do I have good enough internet on site where I'm just going to be uploading the data through Flight Hub 2, and that's basically going to be able to be done through any computer that has an internet browser on it that I can import in my SD or micro SD card, and then let Flight Hub 2 process it rather than me having to spend multiple $1,000s on a processing unit that can work in the field. Also, when we're talking about once we have captured the entire site, it's then important to know, am I going to be processing this locally? If I'm going to be spending money on a processing computer or a gaming computer essentially to be able to process that data set, or am I going to be utilizing a subscription-based service where I'm going to be uploading that data to the cloud for them to process? Obviously, a subscription-based service is going to cost a little bit more when you're talking about a monthly bill or an annual bill to be able to process and host your data, but you don't have that large upfront cost of building out a computer or a PC that's going to be able to process these large, potentially large data sets that you have. And thank you very much for joining this video. It's something that we really need to understand before we dive into being able to truly build missions, whether it's slope missions, geometric missions, point of interest orbits, or smart 3D capture missions. So if we can go through and get a lot of these questions answered, that's going to bring a lot of clarity on what needs to happen on site so that that process goes smoothly and we can start making accurate estimations on how long it's going to capture, as well as what the outputs are going to be for the end user or client. So if you have any questions, definitely reach out to DJI Enterprise team and we're happy to help out. Thank you.